Assalamu alaikum and welcome back everyone, chapter 35 of the Arduino series. In this video we're going to cover switches/buttons. I'm going to go over the two possible arrangements that you can have it within the circuit. I'm also going to go over and slightly touch upon pull up and pull down resist. Now the components you're going to need for this video are a breadboard, the Arduino, 5 male-to-male jumper wires, a switch, 2 resistors and an LED. Now if you noticed in the intro there was two methods of using the push down button. The first one is called a toggle switch. It also goes by a few other terms called self-holding or alternate operation. Now it's used to permanently change the state of itself or the component that it's in charge of. Now the default state that it is on depends on the type of resistor that you connect it to, whether it's a pull up or a pull down. Now a pull up resistor works opposite to a pull down. If the pull down resistor gives the state of the switch a 0, a pull up resistor will give it a state of 1. Now since I'm only going to be using the arrangement of a pull down resistor, I'm not going to explain the pull up. Now if you look into the diagram and you compare both sides, the pull up and pull down resistor, you will notice that the white wire that's in charge of detecting the signal is always on the same side as the resistor. This is important as if it is not, it will give a float value where it would fluctuate between 1 and 0, which is not what we want. The easiest way to identify whether a resistor is acting as a pull up or a pull down is to look at whether the resistor is connected to the ground or connected to a power supply. If it, in our case, is connected to the ground, then it's going to be a pull down. If it's connected to a power supply, it's going to be a pull up. Now, before we move on to the circuit layout, let me explain how the button works. There are a total of 4 pins, 2 pairs. Each pair is angled towards each other. And the pair that are not angled towards each other, there is a switch in between them that is only activated once the push button is pressed. However, the default state of the button can be changed depending on what type of resistor you used. Now, because of the way the terminal strips are connected, we want to place the button over the center divider. This will allow us to form a parallel circuit which we will use to detect the state of the button. Next, you want to take a wire that's connected to the 5 volts and connect it to one of the sides of the button. Now on the same pair, however on either side, you want to take a resistor and further connect it to a ground pin. On the same pair but opposite to the resistor we just placed, you want to take another pin and connect it to pin 10 of the Arduino. Now this part here is optional, you do not need an LED, however I'm going to utilize an LED just so I'm able to explain it better. Now pin 5 of the Arduino is going to be my LED pin, and on the same wire I'm going to connect the resistor, and on the resistor I'm going to connect the long side of the LED, and the short end will be connected to the ground. Now this video is going to be a little bit different compared to the videos that I've done in the past. We're going to cover 2 different codes for the 2 different button functions, and we'll begin with the first one. It's commonly known as the toggle switch, and the script for it is quite simple compared to the alternate operation. Start off by opening up your Arduino software and go to the tools tab on top and make sure that your board and your port are connected correctly. We'll begin with the variables. We have a total of 4 variables. The first 2 are for the pins that we're going to use. We're going to have the LED, which is the pin 5, which is the one that's connected to the LED, and the switch pin, which is what we connected to pin 10. Switch underscore status is going to be our next undefined variable. I'm going to define this later on in the void loop. However, it's going to store the status of our button. And dtime is going to be the variable that's going to store a value that I'm going to use for the delay command. In the void setup, we begin by activating the serial monitor by using the command serial.begin with the baud rate of 9600. Now the switch pin, which is pin 10 for me, is going to be an input for the simple fact that the data is going to flow from the button, or going to collect the information from the button and going to flow towards the Arduino. And we also have to tell the Arduino what type of pin the LED pin is going to be. Since the data is going to flow from the Arduino towards the LED, it's going to be an output. Now using pin mode for both of them, you want to make sure that your M is uppercase because the command is case sensitive. In the void loop, I define the switch status variable, making it equal to digital read switch pin, which is pin 10 for me. Make sure that it's digital read, not analog, for the fact that first of all, you can't control the voltage through the pin, and we also want to tell the Arduino whether we want the LED to be high or low. Now, utilizing the command digital write, we tell the Arduino that the LED pin, which is pin 5, is going to be determined whether it's high or low by the switch status. Now, the switch status is going to be a high when the button is pressed. It's going to be a 1. When the push button is not pressed, it's going to be a 0, and it's going to tell the Arduino it's going to be low. So the LED is going to be turned off. Following this, I told the Arduino that I want the text status of switch to be presented onto the serial monitor using the command serial.print. Serial.println is the command that comes after, and it's going to present the status of the button. And just so that the values that are presented are more coherent and I can see them better, I'm going to use a delay command with a value of 250, which is 0.25, a quarter of a second, or 250 milliseconds. Opening up the serial monitor, you can see that when the button is pressed, it's going to give us a value of 1, and when it's not pressed, it's going to give us a value of 0. Now the second type of switch is known as alternate operation or self-holding. Now this is when the button is pressed once and the status of the component is changed to a constant. In my example, when I press the button once, the LED permanently turns on and it won't turn off unless I press the button again. Now the layout of the circuit is going to be the same as we had it previously. And now we'll begin with the variables. Now the variables that we had for the switch pin and the LED pin are going to be the same. I'm going to introduce something called the LED status, which is going to be the condition of the LED, and it's going to be low, so meaning that the LED is going to be off. And similar to this, switch status previous is also going to be equal to low, and it's going to store the old value of the variable switch status current. Finally, I'm going to have a variable called dtime, which I'm going to use in delay command equal to 500, which is 0.5 of a second. The void setup is also going to be the same as we had it previously. Activating the serial monitor using the command serial.begin with the baud rate of 9600 and telling the Arduino that the switch pin is going to be an input and the LED pin is going to be an output. In the void loop, this is where it gets a little bit tricky, so bear with me. I begin by defining the variable switch status current, making it equal to digital read the switch pin. This will give me a value of either 1 or 0. Next, I begin by using an if statement. I open the brackets and I use two conditions. The first one is that if the switch status previous is equal to 0, which is off by default, and using double and signs, switch status current, which is the variable we just defined, is equal to 1, then we tell it to do two things. But before we move on to the other possibilities, let me elaborate. Now when we start the code, the switch status previous is always going to be equal to 0 because we previously already defined it. However, the switch status current is going to be off because we did not press the button. And if they're both off, that means nothing's going to happen. However, once we press the button, the switch status current is going to be equal to 1, and therefore it's going to take an action path. But the real value in dividing the button into two variables is that if we were to hold the button, the switch status previous is going to be equal to 1, and the switch status current is also going to be equal to 1. But the Arduino will perform nothing because it's not a condition that we have. And this is because we don't have a function for it or an else statement for it. The only else statement is within the if statement. Now there's an if statement within the first if statement, saying that if the LED status is high, then make it low, which means we're going to turn it off. Now, so that we don't have to make an opposite option, we just use an else statement. The opposite option would be that if LED status is low, make the LED status high. And now we're finished with the if statement. Now I use the command digital write LED pin and have its status, whether the pin is high or low, determined by the LED status that we change in the if statement. I also come and I make the switch status previous equal to the switch status current. And this is because so that we can have the switch status previous in the if statement changed to 1 so that the Arduino doesn't constantly turn the LED on or off. Because if we do not do this, the switch status is always going to be constantly on because we defined it previously in the variables. And next I just go through a series of serial.print and serial.println just so that I'm able to express the values of the different variables that I have. And finally the delay command is used so that I can see the serial.print commands every half second. But you also have to keep in mind, because of the way the delay command is placed, you have to hold the button for half a second in order for the LED to be turned on or off. Now I could find a way around this, but I'll say that it's your homework to do so. Now opening the serial monitor, you can see that everything is 0 until I press it, and when I hold it, everything becomes 1. And when I let go, the switch status of the old and new also becomes 0. However, the LED status becomes 1, and this means that the LED is on. And when I press it again, the LED status turns off. However, the new and old switch status turns on. Now, if this video has benefited you in any way, consider giving it a like. And if you wish to get closer to the community that I'm trying to build, click on the subscribe button, and my Discord is going to be linked in the description. And in the Discord, you can access the 2 codes that I've used in the video. And if you are uncertain about something because you didn't understand it or I didn't explain it well enough, you will find me active on my Discord.